Hello everyone, welcome to my course Python for Data Analysis. In this module, I'm going to talk to you about graphic libraries available in Python. Python has powerful graphic libraries such as Matplotlib, Seaborn, and Plotly. These libraries can be used interchangeably, and some of them are very good for some special purposes. So today I'm going to talk to you about Matplotlib. Before we dive into Matplotlib, I want to bring in the data for our analysis. For today's data analysis, I use weather data from Indonesia. There are several weather stations scattered around Indonesia, and we use the data from these weather stations. And this data set contains the date to represent the time, and minimum temperature, maximum temperature, average relative humidity, rainfall in millimeters, then duration of sunshine, maximum wind speed, wind direction at maximum wind speed, average wind speed, most wind direction, and station ID, which records this data. So this way, if you have the station ID, you can use that to locate where this particular station is located on the Indonesia. So we can use this. I'm using this climate data.csv file here, and if you use this climate data CSV file, you will get all these parameters. Then you can match this station ID with station detail CSV file. So I got this data from Kaggle datasets. If you go to this particular link, you can download this data. This is an amazing data. This is of a 11 years of data starting from 2010 and ends 2020. So the one thing I didn't like about this data is that how they named the columns: date, tn, tx, t-average. So for our purpose, I thought that it will be nice if I change this column names in more readable way. So I converted that into date, the same, no change, minimum temperature, maximum temperature, average temperature, relative humidity, rainfall, sunshine hours, maximum speed, then wind direction at maximum speed, then station ID remains the same. I haven't changed it. Then I used pandas read CSV to read the data. So I used the read CSV and read this particular data, climate data.csv, to my workspace. I used columns 0, 1, 2, 3, 4, 5, 6, 7, 8, and 11. I skipped the columns 9 and 10, which are wind direction at maximum wind speed and average wind speed. We really don't want that for this particular demo. And date, I used the parse date keyword and read the date into date time format. Then now I have new names for my columns. I used my custom names for my column names. Let's see what is there inside this data frame. So df is our data frame. So inside this data frame, we have about 500,000 data points from 173 stations, and start date is 2010 and end date is 2020. Why it didn't print end date? Let's see. Yeah, now the end date is here. So the end date is 2020. So we have data from 173 stations, which spans from 2010 to 2020. So this is a lot of data. This data is really good. As I told you, almost 500,000 data points. It can be used for several purposes. If you want to try out a machine learning algorithm, you can use this. But for our purpose, we really don't want to dig deep into this many numbers of data points. So therefore, I limit myself for this particular analysis to only five stations. 1, 2, 3, 4, and 5 stations, and I read that into another data frame. I call it df subset. So this is a subset of the big df data frame. Let's run it. So now we have our data. We have a df subset data frame which consists of 5 stations weather data from Indonesia. Okay, now let's go to the Python graphics, and in this lesson, after this lesson, you will learn how to convert your data into charts such as line plot, bar chart, scatter plot, histograms and box plots, etc. And how to change your graphic properties. You want to change the color of your graphic, you want to change the size of your graphics, you want to change the line width, marker size, etc. You will learn that, and you will learn how to add a label to your x-axis, y-axis, how to add a title, how to make subplots, things like that, and how to save your figure into a format which you like, either PNG or PDF or a JPEG, formats like that. And also you will get the fundamentals of data storytelling, how you can effectively use your graphics to tell what is there inside your graphics or what is there inside your data. So that is also a fundamental requirement for your data analysis journey. Okay, let's dive into Matplotlib. Matplotlib is a fundamental library that most of the Pythoners use. It's a for making simple line charts, scatter plots, bar charts, things like that. This is your go-to library if you want to make something, if you want to convert your data into a chart. This is your first go-to library. So this is very easy, and it easily converts your data into graphics, and syntax is very easy to remember. It can generate 2D graphs, 3D graphs, as well as contours. It can be saved into, say, almost all graphic formats like bitmap, or if you want to change that into a vector graphics, of course you can do that. PDF, yes. PNG, yes. TIFF, yes. JPEG, yes. You can convert into as many formats what you want, and it can make very good quality publication ready graphics. Okay, let's go to a simple line graph next. So these line graphs, these are very good for time series, to represent time series of data. For example, you have stock market price increasing or decreasing, what is happening in the stock market, or what is happening in the housing market, what is happening excuse me, what is happening in a product line, whether you are making more products or you are selling more products, things like that with respect to time, over 1 month time, or over a quarter time, over a year, or over a financial year, how these things are varying. So for that, the time series is very good, and you can use this type of simple line graphs. So here what I'm going to show is how the temperature changes at 5 Indonesian stations over the years starting from 2010 to 2020. Let's plot it. Then we will go one by one. So see here, we got the line plot, and you can see this nice sinusoidal variability in the graph. So this starts at 2010 and ends at 2020. So 11 years of data. So what is this sinusoidal variability? Let's think about that first. The sinusoidal variability is because of the seasons, warmer seasons and cooler seasons. So warmer seasons you have higher temperature, then cooler seasons you have lower temperatures. So summer and we have some, Indonesia have summer of course, but it does not have winter as that we see in temperate climates. So it has a cooler season, sometime starts in November and ends sometime in January, February time. So that's when you get cooler temperatures. So that's why we see this sinusoidal pattern in the temperature. And in addition to that, you see some line plots, horizontal lines here. This is because this is first station plots all the way from 2010 all the way to 2020. Then once it reaches the end, it need to go back for the second station. So it will make a line from here to here, then it replot again for the second station, then again third station, then again fourth station, then again fifth station. That's why we see these horizontal lines in between. If you want to remove that horizontal lines, you can do that. You just need to pick up each station separately and plot it. Or other way, what you can do is that you can, instead of line, you plot it as a dot plot. See, now you cannot see that lines, annoying lines are gone. Then what next? So let's go line by line. I'm going to change this back to a line figure instead of the dots. So here what I do is that here I define a figure which has the size 20 by 9 with a density of pixels per inch of 300. That's what this line does, and this is the actual plotting line. So plt.plot. So I called our matplotlib .pyplot as plt. That's how I imported my matplotlib here. So that's why I call it as plt. Usually we import it as plt. Okay, so come back here. So plt.plot. So this is our x. So the first argument is the x-axis value, and second argument is the y-axis value, and this shows what kind of plot we want, a line plot. And this label shows that we can put in what we are drawing here, what is our graphic is all about. For me, this is average temperature, so I labeled it as average temperature. This label is very useful later on when you add a legend. I will show you very soon. Okay, so that's what this line is about. Then if you want to put a x label, you can use plt.x label. So my x label is date, y label is maximum temperature, you can see here. Then I put a title also, air temperature at 5 stations. And if you want to in Indonesia, you can add that also. So now let's see. So now it updated air temperature at 5 stations in Indonesia. Okay, it all looks good, not bad, very nice. Let me move this a little bit this side. Okay, now my next idea is I want to add more data into this. For example, I want to add, instead of in addition to the average temperature, I want to add minimum temperature as well as maximum temperature. So here this line adds minimum temperature, see, against the x-axis date. Then this adds maximum temperature. Let's plot it and see how that looks like. Cool. Okay, so this one for the time being I'm changing into a dot using a marker. Okay, so now I have maximum temperature. I don't want to do this right now. Okay, plot it again. Okay, so now I have my minimum temperature in blue, maximum temperature in orange, and average temperature is in green. But now I'm thinking that, my maximum temperature is in orange, but I want red for my maximum temperature. You can easily do that. Here is your maximum temperature, and what you do is that you add an R which represents red. Okay, we got red. But what happened is that Matplotlib automatically changed our average temperature into orange, which I don't want. So I want to get that green. So I put that green. G represents green. We got our green back. And here minimum temperature, it is blue. You can also indicate the color, or also give color names using the color argument. Color equal to For example, I want to use a Dodger blue color, which is a lighter version of color which I like a lot. See, and this red, not very good. I want to change it into a better red color, so I can do that here. Color equal to tab red. So this is the red color used in Tableau, a data analysis and visualization software. So this is how tab red looks like. And another one, for example, instead of tab red, sorry, I will keep this as tab green. Color equal to tab green. Let's see how that looks. Wow, this is the tab green. And instead of tab red, there is another color which is called tomato. See, so this is another version of red which I like very much, tomato and Dodger blue and tab green. So this way you can change the colors. If you go to the Matplotlib documentation, you can see that all these, how many different kind of colors are available and how you can use it. And if you like some color patterns, use it. Okay. So next is that what I want to tell you is we can limit our x-axis and y-axis. So here I plotted all the way from 2010 to 2020, which I really don't want. If you think that I want to show only 2018 temperature variations, I don't want to show all these 11 years of temperature. What you can do is that you can use xlim command, xlim. So xlim minimum comma maximum. So here minimum is 2018 1,1. I change that into a date time object. Then maximum is 2018 12/31, that is December 31st of 2018. Let's plot it. See, now your graphics shows that this particular chart shows from 2018 January to 2018 December. Very good. Then what next? What next we can do is that we can limit similarly the y-axis. So here it shows all the way from 15 to 40 degrees Celsius. I want to limit that into say 37, because we do not have 40. And here instead of 15 I only want to go for say 18. So let's change that into 18. So now it is from 18 to 37, our y-axis limit. And font sizes also you can change for X label, Y label and Z label, and you can update the font size using this command, rc-params update. So you can increase the font size the way you want. If you want to decrease the font size, you can do that. So all these options are available. And finally, if you want to save this data into a PDF format, that's what I did here. This is the command that we can use for PLT save figure. Let's see where that is. Time series.pdf. See, now you got your nice figure in the PDF format. You can use it for, if you want to copy this into your PowerPoint presentation, or if you want to use this for any of your documentation or publication, you can use this figure. It's that easy. And one thing I missed to tell you is about the legend. So here, as I mentioned earlier, we use the labels here: min temperature, max temperature, average temperature. And if you call this particular command plt.legend, and if ends with the bracket, then it automatically put the legends here. So now you know what is your minimum temperature, blue, what is your maximum temperature, it is red, and what is your average temperature, it is represented in green. So it's that easy. Okay, now let's go to another type of plot. It is the scatter plot. Before I'll dig deep into that, we'll plot a simple one. Okay. So scatter plot basically we use to show the relationships, or to check the relationship between the parameters in your data set. Here I check the relationship between temperature and relative humidity. You can check the price of house in the housing market. What is the price of a house related to the number of bedrooms? So naturally, lower number of bedrooms have lower price, and if there is a higher number of bedrooms, that house is generally going to be a big house, so it's going to be more expensive. So that way you can see that what is the relationship between number of bedrooms and price of the house, things like that. So you basically use this scatter plot to see the relationships. So here let's me comment this before I go further. And I don't want a 29, let's go by 10 by 10 size. Okay. So here what you see is that average temperature versus relative humidity. So you can see that as the temperature increases, that's what you see here. As the temperature increases, the relative humidity decreases. So for temperatures higher than 30 degree, you consistently get relative humidities less than 60%. So that's what you see here. So that is the relationship here. So you can, if you fit a line here, you might end up a linear fit here, starting from here all the way here. So that is a relationship, that how your temperature and relative humidities are related. Okay. In addition to this, in Matplotlib, you have some additional parameters like S. So the S stands for size. So here I use the S equal to for the rainfall. So I use the size of this scatters to represent the rainfall. Let's see how that looks like. See, so now it is not the same size. Your scatters are no more same size. Let me go back to this 20 and what was that, 9, right? Okay, 9. So this is more easy to much easier for me to visualize. Yeah, so coming back to our problem, so we have now different sizes of markers. So the tiny dots represents less rainfall, and bigger sizes of your marker, the bigger the marker, the more rainfall. That's what it shows. So if you look at this again here, if your temperature is somewhere higher than 29 and if your humidity is less than 60 or 65, you won't get that much rain. That's what this shows, this chart shows. But if you have a humidity higher than 80% and temperature less than say 27 or 28, there is a chance for that you get more rain. So this way you can interpret your results, what you see in your data. You can tell your audience what you see and how you can interpret in that you see in your data. So in addition to that, excuse me, we have another parameter known as C. So C represents the color. Okay, so here I use the maximum wind speed for the color. Let's plot it. So this is how does that looks like. So we don't know what is this variability is that. To show that, we can add a color bar to this. So the color bar shows that our max wind speed varies from 0 to 50. So mostly it is very close to less than 10 meter per second, but there might be some, see here for example this one, it's really high, and here you can see really high values. So you can limit your z-axis. So instead of 0 to 50, if I want to limit that to excuse me, 0 to say 10, we can limit that. See now it is much better visualization. So that way you can play around with your z-axis and find out you can strike a balance between your data visibility as well as how you want to explain your data to your audience. So for that you can tune your z-axis limit. So that's all about scatter plot. Then another important type of chart is the bar chart. So the bar charts are very similar to time series plots, but it can show that how is this discrete variabilities in your data. For example, stock market changes in stock market, the price of a particular stock, or how the price of or how the indices changed, census index, Nasdaq, things like that. Or you can use the bar chart show that how the revenue of your company changed from this quarter to next quarter, things like that. So it is basically easy to show, or it is easy to compare than the time series plots. So for this analysis I'm not taking all the data. I'm taking only a data from one station, 96011. So I call that data frame as df96011, and I haven't defined subplot yet, so this is for another idea. Just ignore it. So let's plot it. It took a while to show up. So here what you see is the data of rainfall from this particular station, 96011. So, and only I limited the time from 2018, for the year of 2018. So if you look at here, what you can see is that you got very good rain, 75 millimeter of rain on this particular day. Then there is no rain for next few days, or next few days. Then a good rain event, then some small rain events, then again then rains comparatively reduced, then there is a spell of no rain, then another day of a lot of rain. Then again, if you look at this figure, you can see that this particular station gets a lot of rain towards the end of the year, starting from 2018, in the December time period, it gets a lot of data. So this is not for the entire this is not for the entire 2018. This is only starting from October to December. Let's see what happens if you change this into January. See, this is how if we look at from starting from the January. So from January, if you look at, you see here there is some heavy rain happened on this some time before March, end of the February, and lot of rain occurring towards the end of the year. Starting from October or September, end of the September, October, November, December period, this particular station gets a lot of rain. That's what we see in this chart. And again, you can change color, font size, you can add date, X label, Y label, title, everything to this figure also. Now I'm going to talk to you about subplots. So if you want to show two graphs or two charts in the same figure window, that's when we use the subplots. So here, let's go ahead and run it. So here you get two plots in the same figure window. The left hand side you have a histogram, and the right hand side a box plot. As usual, let's go back and see how we did this. So here excuse me, I created a figure window, this total figure window, that's what represented by figure, and inside that figure I created two axes, AX1 and AX2. And this is the command you use, subplots, to create the subplots. This 1,2 represents one row and two columns. So one row, I have only one row here, and one column for histogram and another column for box plot. That's what it basically shows. So that is what this 1,2 represents. And again, you can use figure size to give your desired size for your figure. Okay, so what I showed here is in here x1 hist. So you give x equal to wind direction at max wind speed. So I basically showed the wind direction, how the wind direction, what are the wind direction means from which direction the wind is coming to this particular station. So I want to bin it and see that from which direction I get maximum number or maximum count of higher winds. That's what I'm going to look into. So R width basically shows that the width of this bars. Then bins shows that how many bins you have to, how you want to bin it. So I want to bin it from 0 to 360 degree because wind we get wind direction in degrees. So 0 means north, and 360 again it's north, 180 is south, then 90 is east, 270 is west. That's how it works. So I want to bin it in 45 degree bins. Then axis limit, ticks, wind direction, you can change all these parameters the way you want. So let's examine this first figure. So here what you see is that between 0 and 45 we have 300 events, that 300 maximum wind events. Then 45 and 90 we have about 350 or 370. But if you look at 135, between 135 degree and 180 degree, which is basically southeasterly direction, you get about 800 events. And similarly between 270 and 350, which is northwesterly direction, you get maximum winds about 800 times. So this and this are almost the same, equal number of events happening between 135 and 180 degree and 270 and 350 degree. That is southeasterlies and northwesterlies happening. When southeasterlies and northwesterly winds happening, we get maximum events or maximum number of higher winds, very strong winds. That's what basically this graph shows. Then another graph type is the box plot. Box plot basically shows the distribution of your particular parameter. Here I showed the distribution of the maximum temperature. So this is how you, the syntax, x2 box plot and what parameter you want to use. And nans are not, the box plot in Matplotlib doesn't like nans, so you have to remove that nans. You can use drop now command from the pandas. Then again x label, you have, sorry, I set y label. Then I put a sup title, super title for this corresponds to both these figures. So you can independently put titles for example, if I want to x1 dot set title, then for this what we call it histogram wind direction. Then for the second one we can put a independent title ax2 dot set title histogram, sorry, box plot of max wind, sorry, max temp. See, so what this basically shows that we got the independent titles for each subplot, and we can put a super title for both these subplots. So the size of this is a little bit small, so I will change that into 20 to match with this one. So that's what you see here. And again, Let's come back to the box plot and examine it a little bit more. So what is box plot? It has a box and two whiskers here. So this lower and upper whiskers shows the minimum and maximum of this minimum and maximum in this distribution, and rest of these data points shown by these open circles is considered as outliers. Then what next? The lower part of this box is 25th quartile, 25th percentile, and the upper part is 75th percentile, and the middle orange line is the median or 50th percentile. So that this way, if you have more parameters, you can easily plot that into a box plot and see what is their distribution. Is there any outliers in that, and what is its minimum, maximum, where is its median lies, things like that. So this is very important. Box plot is very important for statistical analysis. I'm not going much deeper into this, which is that is going to be in another session for the statistical analysis using Python. That time we will learn more about box plot. So I'm going to stop this here, and next time we will talk about Seaborn. So I'm going to conclude this here, this session. So what we learned about what are the libraries we need. We talked about the International Weather Station data and how we rankled the data the way we wanted, and how we looked into the data and see what are there. We got some idea about the data, and we took only 5 stations from our data set, not the entire stations, which is enough for our excuse me, enough for our purpose, our data analysis purpose, or this demo. Then we learned about line chart and how we can change the color, how we can change line to marker, how we can change the font size, how we can set the limits, how to add a title, then X label, Y label, then how to add a nice legend, things like that. Then a scatter plot, we talked about scatter plot, which is essentially checks the relationship between the variables, and how we can use the S for size parameter, C for color parameters, how to add a color bar, how to limit the axis of the color bar, things like that. And here we also learned about how to save the data. That's save the graphics. That's very important. Then we talked about bar chart. We showed how the rainfall varies at a particular station in Indonesia. Then we talked about subplots, histograms, and box plots. What are their importance? How to interpret them? Things like that. So I strongly encourage all of you to go to this Kaggle site, download this particular data, and get your hands dirty. Try out this and let me know how that goes. And don't hesitate to get back to me if you have your own data, or if you find some other data, and if you find it interesting. Try out these different kind of charts and see how that looks like. Is that enough for your purpose? If it is not, why? Let me know. Let's discuss it and find out how we can proceed, or can we use some different kind of graphics, or we can use some different kind of graphic libraries to address some different problems. We can discuss all of that. So for the time being, go to Kaggle site, download this data, and work with this, and let me know. So again, thank you so much for listening. Have a good one. Bye.